let's start.
Okay, right here. Okay, our group project was the toe prosthetic, and our group members are Jonathan Guerrero and Fenghao Zhang. And so the background and goals for our group project was we wanted to keep in mind diabetes, and we wanted to focus on that because it affects a large portion of the American population at around 11.3%. And so diabetes can lead to complications such as neuropathy, which is um, loss of sensation due to nerve damage. And diabetes also leads to increased risk of infection in the lower extremities. And so these two complications together lead to a high risk of amputation for diabetic patients. And so in 2018, there were 154,000 diabetic patients hospitalized for a lower extremity amputation in the United States, which is a lot. And the high average cost of lower extremity prosthetics drove us to uh, this project. And so the effects of lower extremity amputation are huge on walking and just normal life. The toes have a large impact on maintaining balance, and they provide support when walking. And so partial foot or toe amputation creates a need for prosthetics in order to provide the weight bearing and help restore natural motion required for walking and things like that. And so the goal of this prosthetic is to provide a relatively inexpensive mobility aid for diabetic patients that have suffered a lower extremity amputation.
The basic truth about process. The process is a kind of valuable technology in medical field. It's helpful for people who lose their limbs. The earliest process origins from the ancient Near East 3000 BCE for aid disabled. Now people use better material to improve prosthesis, and the motto to aid disabled for movement. On the left picture, here is older process which use material as the uh, main material. And on the right one here is a modern process. Our design plan divided four steps. The first step is using 3D printing make a foot model. Next, we will separating toes and other parts of the foot. Then we will manufacture the fiber sleeves for connecting toes and private protect. Finally, we will do some improvement and summary our project. Next.
And the initial designs of the prosthetic consisted of a single toe that would then connect to a sleeve that would fit on the top of the foot. And the design considerations that we want to keep in mind for this were that it should be lightweight, it should be durable, flexible, it should be at a low cost, and it should also be comfortable because after all, somebody is going to be wearing it. And so on the right, you can see a crude drawing of the initial design. In red is the sleeve, um, and then you can see in blue is that support band that would have wrapped around the big foot in the prosthetic, and a stretchy rubber ring in order to put the prosthetic toe in that would then connect to the red sleeve or the sleeve that is in red.
For printing the photo model, we will search a sample photo model at first. Then we will talking about the material which we used. There are two options. One is PLA and the other one is ABS. PLA is a kind of bioplastic, so that it's easy for degradation and less pollution. And PLA printing is not extra small. For ABS in 3D printing should consider heat shrinkage, and ABS printing require a heat bed, while PLA printing not. So that in our uh, project, discussions, we decided to use PLA, which is cheaper and beneficial for our environment. The zoom scale, which we use for about 15.7, the actual size is look like a woman's feet, and the color which we use for the model is white. Finally, we will contact the RVC lab for print our model. This is our photo model. On the right one is the actual model. Next, we will sprinting the toes. Sprinting toes provide a surrounding for process stimulation. After that, our group try to connect toes and other parts of the foot to simulate the process, which is connecting people's feet. After separating the toes from the foot, the inside was filled with plaster to provide stability and weight. On the right picture, here is the tool which we used. Next.
In the end, our final design ended up going with all 5 toes instead of just a single big toe. And the final product was constructed from a sleeve that was sewn from high stretch fabric, which was then sewn to a rigid foam, which in turn was then adhered to the toes. And so on the leftmost picture, you can see just the prosthetic. Um, in the center picture, you can see the prosthetic that is on the patient foot model. And on the rightmost picture, you can see the prosthetic that's in a flexed position. And it is that picture that shows um, how the prosthetic could help with or assist in mobility, as the flexing of the foot is what would occur when walking and things like that. And so some limitations of the product. Well, first and foremost, the product was completely produced without patient input. Um, Without patient input, we can't really see what real usage of it would look like, what real other problems we might not have even thought of we would have to take into consideration. Um, some more limitations are there's limited mobility of it. The prosthetic can only flex with the movement of the sleeve. And but this is also just a simple prosthetic. The intent wasn't necessarily to aid with things such as rapid change of direction or with running. It's just for normal traversal, such as walking or stepping upstairs, things like that. And then there's also lack of variability. The prosthetic was designed and produced with the measurements and the specific amputation of the patient model in mind, that being the small size and the 5 toes that were removed. And thus it will have limited use outside of this specific model. And so if this product were um, done in the future, these would be things that we'd have to take into consideration. And then on the left, you can see that the prosthetic was placed into a shoe. And so that's just a real world usage of it. And then next. And so then moving on to the conclusions of this product, the toes prosthetic is a low cost mobility solution for diabetic amputees, or really for anyone who has suffered a partial foot or a toe amputation. And then we go back to those design considerations, trying to see how we met those. So it was lightweight. The prosthetic weighs less than 45 grams, which is less than your average wireless mouse. Um, this lightweight nature of it will make it so that it won't be too heavy for the user. The durability, no durability tests were conducted in this, but the PLA toes and the flexible nylon fabric should be able to hold up with regular use. The flexibility of it, it is used from a high stretch flap fabric sleeve that can stretch very well and is very flexible. It is a low cost because the total bill of materials was less than $15, which is very affordable compared to the hundreds or thousands of dollars used in a conventional prosthetic. And then it is comfortable. The foam insert on the used in the final product was lined with soft felt on the inside where the foot would make contact. And the fabric is breathable, which would allow for wicking of moisture and also for just general ventilation.
Thank you.